Welcome back to the second part of tutorial on factor analysis. So in last tutorial we have checked the assumption as well as we have identified how many factors to extract. Okay, so in last tutorial we have seen that sample size was adequate, there were sufficient, the variables were sufficiently correlated, and we need to extract 10 factors. So this is we have already completed in first tutorial. So now we will start from the second step of this factor analysis. Okay, so just go to analyze, click on dimension reduction, select factor, variables are already transferred, then go to descriptive, KMO is already selected, and go to extraction. Now as we already know that we need to extract only 10 factors, so instead of selecting based on eigenvalue, we will select fixed number of factors and we will put here 10. Then we will press continue. So now descriptive is done, extraction is done. Now we will come on to this rotation part. Okay, so now come rotation. Rotation actually we perform to create a simple structure of data. Just to create simplify the structure of data, we use rotation. There are two types of rotation. One is orthogonal rotation and second is oblique rotation. Okay, there are few assumptions of both the rotation. Orthogonal rotation assumes that factors are not correlated. That means factors are uncorrelated, unrelated. And oblique rotation assumes that factors are correlated. Okay, so this Varimax is a orthogonal rotation method, and direct oblimin is a oblique rotation method. Okay, so we have to decide whether we need to use Varimax or direct oblimin. Okay, in most of the cases Varimax is used with PCA. That means when you are doing PCA, in most of the cases Varimax is used. Okay, but we cannot decide randomly. We need to check whether factors are correlated or they are uncorrelated. So for checking this, we will select direct oblimin. By default we will select direct oblimin because in direct oblimin component correlation matrix will be created, so that matrix will tell you whether factors are correlated or not. So just give it a try, select direct oblimin and continue, then okay. Okay, all results are there, but we need not to read all the result as we have already checked the KMO, Bartlett and variance explained. We will directly come to the last table of this result. Okay, we will directly come to the last table of this result. Okay, so before we interpret the result, I am just repeating the process again. Go to analyze, dimension reduction, select factor, click on descriptive, select KMO which is already selected, go to extraction and change the extract from eigenvalue to fixed number, and we already know that we need to extract 10 factors, so just put 10 here, then press continue, then click on rotation. So we are not sure whether we will be using Varimax or direct oblimin. So just to decide whether to use direct oblimin or Varimax, we need to calculate the component correlation. Okay, we need to calculate the component correlation. If components are correlated, then we will be using direct oblimin. If they are not correlated, then we will be using Varimax. Okay, so for this just click on direct oblimin and press continue. So before we press continue, another option we need to rectify this, the iterations. It means how many iterations this software will perform for analysis. By default it is 25. It is good for when your variables are less in number, but in our case we have 45 variables. Okay, so this 25 will not work, so I'll just increase this number to 50. So we just need to increase this number to 50 because 45 variables, so 50 is sufficient. Okay, and then I'll press continue and OK. So now result is with me. So I'll directly come to the correlation component matrix. I'll not going to read all the result. I'm just directly going to last component correlation matrix. Uh, this is the component correlation matrix, which is explaining correlation between different components. There are 3 factors. There are 10 factors. So 10 factors. This is showing the correlation. Okay. Now the thumb rule is, if any of the pairwise correlation is more than 0.3, then we will consider that factors are correlated. Then we will use direct oblimin. If all the factors, all the pairwise comparison is having correlation less than 0.3, then we will say there is no correlation, the factors are uncorrelated. And in this case, we will be using Varimax. Okay. So just check one by one. Component 1 with component 2, it is 0.07, with 3, 0.75, 8. There is no correlation is greater than 0.3. We need to skip these diagonal correlation, because this is correlation of factor 1 with factor 1 only. So it will always come 1, because it is absolutely correlated. Okay, so we will skip these diagonal value and we will check all other value. If any value is more than 0.3, then we will perform this direct oblimin. If all values are less than 0.3, then we will perform Varimax. So in this case, just let me check. All are less than 0.3, all are less than 0.3, all are less than 0.3. That means there is no value in excess of 0.3. That means our variables, our components are unrelated. They are not related to each other. There is no correlation between factor. So we need to use Varimax. So now we are done with all the primary work of factor analysis. We know that assumptions are fulfilled. We know we need to extract 10 factors. We also know we need to perform Varimax notation. Okay. So now I am just cancelling these results. So now I will perform finally the factor analysis. So just simple, go to analyze, click on dimension reduction, select factor. Okay, in descriptive we need KMO, which is already selected. In extraction we need principal component, which is already selected, and we need fixed number of factors extraction, and maximum number is 10. So we have already filled this information. Rotation, this is most important. Rotation, previously we have performed direct oblimin, but direct oblimin is not applicable in this case, because factors are uncorrelated. They are not correlated with each other, so we will be using Varimax. Now press OK. So this is the final result of factor analysis. So these are the final result of factor analysis. Now the question is how to interpret these results. So one by one I will explain all the tables. First table is KMO, which we have already interpreted. That means KMO explain the sample size adequacy. So KMO value is 0.841, which is more than 0.6. That means sample size is adequate. Second is your Bartlett test of specificity, which explain whether variable are significantly correlated or not. So this is also significant. This is also less than 0.05. That means our variables are sufficiently correlated also. We can perform factor analysis. Okay. These communality table, this is the communality table. You need to check. This is communality table. Basically, in communality table, the all value should be in excess of 0.5. Okay. If some factor is if some variable is having value less than 0.5, then that factor will create some problem at the time of factor loading. Okay. But in our case, most of the values are above 0.5, so there is no problem of communalities. Okay. Now this table we have already explained. This table is explaining that we need to extract 10 factors. So we have already extracted only 10 factors. Okay. One important thing about this total variance explained table. This is we need to check the cumulative variance. We need to check the cumulative variance. That means whatever model we are forming with the help of this factor analysis, this model will explain 58.289% variance. That means these 10 factor will explain 58.289 variance, 58%. Okay. Next, the most important table, that is rotated component matrix. This is the most important matrix, rotated component matrix. Actually, this matrix explain you which variable to club with which factor. That means in factor number 1, what all variables will be included. Okay, simply you just need to see that this first variable, it is loaded on factor number 1 0.142, on factor number 2 0.658. That means we have to load this factor into this variable into second factor. Okay, so now it is very complicated. So what I do, I just remove all the factor loading in less than 4. So we will remove all the factor loading which are less than 0.4. So this table will be more clear then. Okay, so just go to analyze, select dimension reduction and factor. So this is the option. So just go to option and suppress small coefficient. So any coefficient less than 0.4, just suppress them. Okay, so all the variable will be removed automatically. So now if we can see the revise table, so revise component matrix table. So now you can easily see rotated component matrix. Now you can easily see, that means which variable should be loaded on which factor. So factor number 1, that means this variable, okay, we need to check rotated component matrix. So variable number 3, variable number 9 and variable number 15 will be loaded on first factor. So first factor include these many variables. Okay, so now all the variables are with us. So these variable will be clubbed on first factor, and these variable will be clubbed on second factor, these variable will be clubbed on third factor. So now every factor will be created. Now we can create all the factors. So what we will do, we will club this variable, these three variable, this variable fourth, and this variable fifth, this variable sixth, this variable 7, this variable 8th, and 9. That means these 9 variable will be clubbed into one single factor, because these 9 variable are common in nature. Okay. Similarly, in second factor, these variable will be clubbed. So variable this 2, and you can see this 3, this 4, 5, 6, 7. So these 7 variable will be clubbed in factor number 2. This is how we can club all 44 variables into these 10 factors. Okay, so this is all about the factor analysis. This is all about reducing the dimension of data. So now we have reduced these 44 variables into 10 factors. So which factor will include how many variables? This will be decided by the rotated component matrix. So all the variable which is showing in factor number 1, these will be clubbed in factor number 1. These all variable will be clubbed in factor number 2. Similarly, all these variables showing in third component column will be clubbed together. So this is all about the factor analysis. I hope this tutorial will be helpful in your study. Thank you, all of you.